All right, starting recording. We will go over Sudoku in just a little bit. Let's start the day off with, it's been about 5 minutes. Let's get those feedback forms filled out. How you feeling? We're starting to enter week 3. You had an assessment on Friday at the first group project, so just let me know how you're feeling. So it'll take about 5 minutes, 9:05. We'll get started with, 9:05, we'll start getting started with all the stuff we have for today. Not a small amount of stuff, but not a large amount of stuff either. A lot of this we did cover last week. If you haven't seen, I have graded all of the assessments. I'll probably just start pulling you all in one by one, just to kind of go over each one. I'll talk a little bit more about that later, but if you haven't seen your score, it is on your pull request directly on there. I was to try to be as objective as possible.
Yeah, I sent in the, I'm sorry, I sent in the corrections for you.
Yeah. Don't hit the merge button for everyone. Don't hit the merge button on the bottom, because then that becomes like the new master. So Aaron, you hit the merge, and I was like, so when everyone closed now, we're gonna have Aaron's answer inside of this. I reverted it. It's not a big deal, but I promise I'll publicly shame everyone. Don't hit that merge button. Don't push to master if at all possible. So again, if you're just calling in, we'll be here about until 9:05 or so. We're going to, and what we'll do is we're going to fill out those feedback forms just for us to know more or less where you're at. Oh, my camera shuts off whenever I share screen. Are you using that iPad back there? Your iPad?
No, you want it?
Well, I can try it out.
It's a really old one, so.
Probably.
Try it out. Sure. For.
Well, when I sign up for when I share my screen, it actually just stops.
Okay.
Password. Good to go. All right, last minute for these feedback forms. What's that? Yeah, you might as well tax it and see how far it gets. Rod, why don't do you want to start off this morning talking about the internship program before we get started? As we're waiting for everyone to get situated, a few things on the I think you have to turn up your sound, Rod. Yeah, here you go. All right, as we're just waiting for now, a few things going on this week. Today, Charlie Platoon, Darnell Gilead is going to come in. He just got a full-time offer at a company called Coyote Logistics, which is a UPS company for shipping, working in a language that he has no experience. He had no experience in C Sharp, C++. One of those C languages that's C Sharp. Okay, C Sharp.
We just posted C Sharp, C++.
Very different. So he's in C Sharp. He's going to come in at 5 today before his TA session starts. So we'll have everyone calling in around that time. Mike will set everything up. Can somebody grab the door? Tomorrow, Andrew Klitsky will be here all day again, and we're going to have a career prep from 5:30 to 6:30 again. Remote will send out probably a Zoom link for that one, and we'll do our best to record that one as well. These are two professional recruiters who look at resumes and hire people all day long. One of them is from I think it's G18. It's a government, G18 or something like that. It's a privately held company that only takes government contracts. So it's very, very stable job, lots of huge contracts and things like that. Only hire the best. And the other one is a local company called ParkWiz, which is in a parking garage or something like that. And they have extra spaces or something like that. You can go online and basically book it for a little bit cheaper. And that's, it's a pretty cool concept. We'll have our third Beyond Tech where we're going to talk about diversity and inclusion Wednesday. And then on Thursday, we're going to have a person coming in from DRW Trading, which is a proprietary trading firm here in Chicago. What that means is basically they take like a small, like a pool of money, and then they basically make more money out of it at the very base of things. But Chris Walquist has been with us since Bravo Platoon, if I remember correctly, and he's been teaching this lecture on like a really deep dive into how Git works locally on your machine. So he's going to be here for a couple hours. Again, we'll set everybody up so you can watch that as well. It's going to be from 10 a.m. to 12 on Thursday. You're going to have a second assessment. I should probably add that. Assessment 2 will be on Friday. It's going to be on object orientation, and it's a doozy, but I think we'll be okay after doing object orientation for the next 4 days. With that, we're not going to be doing much more algorithms. So I'm going to start soliciting people for whiteboarding like volunteers and algorithm volunteers, which means that I'm going to invite senior engineers who interview you, essentially, like who interview people like you, junior developers. They're going to be coming in probably once or twice a week for about 2 hours each time, just to kind of go over a problem. We can do this as a large class, but more than likely, it'll just be a small subset of people. If you want to go, you can go. If you don't want to go, you don't have to go. I will, whenever that person comes in, I'll reserve a conference room, and then I'll send you off over there. And then remote, we'll figure it out. I'll probably send Mike in there and get everybody set up. So I'm going to pass it off to Rod to talk quickly about the internship program.
What is Daniel coming here?
No, he's in the National Guard stuff.
Oh,
I know. Sorry. Yeah.
okay, got it. Okay, so I'm going to talk a little bit about the internship program. So this is necessarily apply for the remote program. You're pretty welcome to listen in.
Can you guys hear him at all? Nope. I will mute this microphone, and then you. Yeah.
Are you muted?
I am muted.
Okay, can you hear me now? Better? Can you turn yours down? How's that? Okay, much better. Okay, so I'm going to talk a little bit about the internship program. This mostly applies to the in-person folks, but remote are welcome to listen in. So as most of you know, there's an internship component to Code Platoon's in-person program. And what that means is that we partner with companies. In this case, we have 2 companies. I'm hoping to get a third, who will interview students at the end of the program. The interviews take place right after the program ends, so week 15, if you will. And students and companies interview each other at the end of the week. Students who participate in this internship program will rank the companies, and the companies will rank the students. the interviews are typically not as hard as they would be if they were actually interviewing you for a job, because they're generally committing to take a placement, or at least they're committing to take somebody. We won't give them just anybody, but we will generally give them somebody in their top half. But so they're generally just interviewing to see what's a good fit, and so it's somewhat technical, definitely behavioral. And after that, students that are in participating in the internship program will get placed at a company for a 3 to 6 month internship. The internship, we require that they pay at least $20 an hour. Sometimes it's more. And that it be a dev-facing role. So it isn't necessarily software developer. It could be QA. It could be DevOps. But almost all the roles to date have been software developers. Most of those that did the internship program ended up getting extended full-time offers. All of those that got offers accepted them. So the placements seem to work reasonably well in the past. So what I want to explain is the nature of the commitment. Right now, none of you are in the internship program. You're all eligible to participate. Most students in the past have chosen to participate. It's really the bridge between our program and full-time software developer is often we need one little more step, and that's an internship, right? So that's why we work so hard to get them. If you choose to participate, then you are committing to us that you will not look for a job or anything else while you are in this program until we have finished placements. Because once you've committed to us that you're going to participate in the internship, we're going to turn to the companies and saying, these are the students that are willing to participate. Again, it's optional, and you're going to have a couple weeks to think about it. So if you don't want to participate, that's fine. But if you do, once you've committed, then it's a binding commitment that you'll accept the placement where it goes, absent, of course, if you get called up for duty or some extraordinary emergency happens. But that's the nature of the commitment that we're looking for you if you choose to participate. Make sense? Okay. You guys have any questions about it?
What companies did you say are gonna? You can't tell us that? Or?
No, sure. The companies this time around are Raise.com and Granger Gamut. So Granger Gamut's kind of an interesting situation. Gamut is a startup within Granger, run by Fred Lee, was awesome. We don't know if the placement will end up in the Gamut side, because Gamut was a startup that was created by Granger, or if it'll end up on the Granger side, which is a much more old line company. So that hasn't been made clear, but it's going to be within Granger, one of those two teams, and then the other one is Raise. And Raise, we have 2 engineers there now, so you guys are welcome to talk to them. Granger will be a new engagement for us.
What's their business?
What does Raise do, or Granger?
Actually, both of them.
Well, they'll come and present. So the companies that are sponsoring will each come to present during this cohort to talk about the companies. But in short, Granger is an old line commercial catalog company. So they stock almost anything that a building manufacturer, a commercial company might need in terms of materials or supplies. So there's a really good chance that this building, when they got these shelves and these chairs and these tables and these chairs, went through Granger. Or toilet paper, or so it's a massive. They're almost like a commercial version of Amazon, only they realize that Amazon's going to eventually eat their lunch, which is why they started Gamut. It's their internal software side platform for trying to become almost Amazon-esque in the way they deliver their product. And then Raise is a gift card marketplace. So if you get an Apple gift card, you don't want it anymore, you can go to Raise, and it's a marketplace where somebody will buy it for some discount. Something like Apple will probably be like 1% discount. But if it's $1,000 gift certificate to Holly Hobby, maybe it's a 10% discount. I don't know. You can go check it out. But that's what they do. And they're pretty big. They're a good sized tech firm here in Chicago. They're kind of an under the radar, pretty meaningful tech team. And their tech team is run by Dave Hoover, who's one of our board members and also one of the founders of Dev Bootcamp. So that's a very, very exciting place to land. So you guys can ask me questions anytime you want about the program. Just want to make sure you know about it. Give it some thought. Talk to me anytime you want about it. All right. I think that's it. Any questions from the remotes? Okay. Yeah.
So you mute.
I will mute.
Mute your sound.
Yeah.
So you say no fintech companies? No, fintech is, unless DRW comes out of the woodwork or CTC. I think the CTC wants to be later, and DRW, I mean, they both just pick up on their own. Innova, they're fintech. Right? They're not trading there. Innova. They do payday lending, so they do short-term loans.
They do subprime lending. But they own companies that do payday lending.
What's that?
They own companies that do payday lending.
Yes.
We were always told it's not payday lending, it's subprime loans.
Yeah, that's more accurate and sounds better.
All right. One last thing before we get started on things for today. We've had a person come in for two or three cohorts now to give what's called a safe Agile Practitioner training. It's a 2-day training. It's going to take place on February 17th and 18th. So that's a Saturday and a Sunday. And the reason I did that is because Monday we have off for President's Day. And he can only come in on weekends. And I figured you wouldn't want to go 7 days in a row. So I put it on the 17th and the 18th. We're flying this person out from Boston. He works with, companies large and small. And essentially what the Safe Agile Practitioner is basically saying, once you get this certification, you can tell large companies like John Deere and PepsiCo and things like that, if you want to bring your company into the future and to learn how to do Agile in a very practical manner, this is one of many different Agile certifications. For all the in-person students, you don't have to worry about payment or anything like that. We will take care of all the payment for you. So you'll have to come in on a probably 8 to 5 basis. And then on Sunday, you are eligible to take the test. Everyone who's taken the test has passed the test. So it's not especially difficult, but it does require you to be here and to pay attention the whole time. I passed by one question, so I could have failed very easily, and that would have been embarrassing for me. If you are remote and you want to come in for it, the cost that we are given is $100 per training/test. For the in-person, we'll cover that cost as part of your tuition. For the remote students, if you want to come in, you just give us $100. That $100 does not go to us. We just pay it out directly to this person who's flying in from Boston.
It actually goes to the organization.
Oh, it goes to the organization, not even to the person.
No, he does this all for free.
Yeah, he does this pro bono because he wants to. He does this pro bono because he wants to. That's what it is.
You pay for his travel.
Yeah. So there's not he's not making any money off this. We're not making any money off this. We just think that this is a good resource and a good title for you to have to differentiate yourselves just a little bit further once you enter the marketplace.
And you told him about Robert, right?
What's that?
And you told him about Robert.
Exactly. Oh, I haven't told them about Robert, but that's a good thing. So we had one student in the Charlie Platoon, and he got a job in working in managed software management in Europe, if I recall correctly. And he says that the real big differentiator between him and other people was having this Safe Agile Practitioner, and he credits most of it to that certification. I said, okay, that's great. So we'll continue to bring it back. If it helps you, great. If it doesn't help you, it won't hurt you. So it'll be February 17th and 18th all day. You'll have Monday off for a day to relax. But if you want to come in remote, we just let us know ahead of time, but you will need to pay $100 for that training. An idea of where we're going. So we are finally in week 3. We're going to be doing mostly object orientation today. We're going to do quasi databases. So quasi databases means we're just going to be reading and writing to a file rather than reading and writing to a database. Next week, we'll do databases. So we're going to do object orientation this week. The whole week's going to be on object orientation, so no more algorithms or no more big algorithms like we usually do. And then next week will be all databases, so all SQL and using something called an object relational map called active record. So yeah, just something to be excited about. Okay, so there were two things that we did on Friday. One of them was the assessment, and the other one was the was Sudoku. I'm going to quickly kind of do my best to get through all of it in like 30 minutes. So we'll see how far we can get with that, because I know some people do have one-on-one starting at 10:30. So I'm going to try to. I have not actually solved this. I don't have an answer to this assessment one, so we'll just kind of go with it and see how far we can take it. The assessments, again, if you click on pull requests here, your assessments will be here, and they're all graded and with comments and things like that. More than likely, I will just pull each one of you aside a little bit later, and then Mike and I will kind of go over like, this is what you did really well on, this is what you need to improve on. Again, these assessments are not like meant to be like a extraordinarily discouraging or encouraging thing. Or, it's not supposed to be a discouraging thing. Let's put it that way. It's just meant to like say like, this is where you're at right now. You know, this is what you need to work on, and we have another assessment this Friday. It's that simple. So let's do assessment number one. Gosh, okay. Let me throw this one away. So we have this optimal change thing, which basically says that this is what I want to get out of it. I'm going to comment all of this out for now. So it looks like I have a change maker object of some sort that takes in two arguments. One of them is how much something costs. The other thing is how much money that you've paid out. And then you just have to just say p changemaker.optimal change, and it'll return this out to you. Using a strictly test-driven development kind of mentality, I'm going to create a file called optimal change spec.rb. You'll notice that these files are named in a specific way. It's whatever the name of the file is, _spec, and that's a spec file for it. At the very top here, I'm just going to do require relative, because I know that I need to bring in my other file, so called optimal change. And I don't know how to write rspec off the top of my head because I'm not a robot, so I'm just going to copy and paste it from somewhere else. I think the phone number one was a good place to start. Okay, I'll just grab this. All right, so just to kind of review test-driven development, the idea is I'm going to write the test first so that I know where I'm going. As long as I know where I'm going, I can always write the code to make it work. Then I just kind of do red, green refactor. So it's like I make sure that I write the test first. It's always going to fail, so it's always going to be red. Then I make it pass. I start writing that code, and then I refactor it afterwards after I see that it worked the first time. So it looks like, if I recall correctly, let's grab all of this and just kind of paste it in here. Looks like we have one method called optimal change. So I'm going to have describe optimal change. Hashtag. This describe block right here between the double quotes is literally just human readable stuff. I put a hashtag in the front just for me to know that, hey, optimal change is a method. It's not a variable or anything like that. So maybe I'll just write a little something like it returns a string as we expect. And this one is as simple as just writing expect changemaker new with this optimal change to equal this thing. So you can think of it as three different parts for this RSpec. So I break it down by given, when, and then. So given, this is basically what do I need in order to set up this test? When, what is being executed? Then is what do I expect the output to be? And that's how we set up every single test. So we start with the describe block. This is like the overarching, like, what am I talking about? I'm talking about optimal change. Maybe optimal change does 3 things or 4 things. But for us, we know it only does 1 thing. It just returns the string as we expect it to. And the way that I break down these tests between the it, do, and end, this whole middle section right here is given, when, then. Given, what do I need to do to set up the test? When, what's being executed? And then what do I expect the output to be? So maybe I want to break this down a little bit. This looks a little messy. So given, what do I need to do to set up the test? Maybe I can have a changemaker equals changemaker.new with 62, 13, and 100. This is what I need in order to set up the test, just to make I need to create the variables to set up my test. When is what's being executed. So maybe I can change this, just do changemaker.optimal change. So the given is this first line. The when is what's happening inside this expect parentheses. And then to equal is the then. It's like, what do I expect it to look like at the end? So I create a variable to set myself up. I expect when I call this variable with .optimal change that the output is going to look a little something like this. So I have this test. I'm going to run it, and I'm going to watch it turn red. I'll write the code. It'll turn green, and I'll refactor a little bit later. So I do rspec of, I don't even know what's in here. Rspec optimal change spec. It blows up. It says there's an uninitialized constant change maker. Makes total sense to me. Like, we haven't written the code yet. So what we'll do now is we'll go back over here. We'll pseudocode this whole thing out, and then hopefully it'll work. Okay, so I know I need a class called changemaker. That's the first thing I know that I need. I know that it's initialized with 2 things. One of them is going to be the amount that you need to pay and the amount that you actually paid. So I'm going to create an initialize. It's going to be total bill and amount paid, or something like that. I like to try to make it as descriptive as possible. First things first, I know I'm going to need these are all instance methods, and instance methods are essentially instance variables are essentially variables that you're going to use within this class over and over inside of other methods. So total bill is equal to total bill, and amount paid going to equal amount paid. Because I know I'm going to be using the @ symbol in the front all the time, I don't want to type ats everywhere, so I'm just going to make this an adder reader for total bill and for amount paid. By making these adder readers, it allows me to use just like, I can just, in some other method, I can use total bill just like a local, it looks like a local variable, but instead it's actually reading the instance variable that's set on line 9. That's what this adder reader does. So it looks like it has one method called optimal change. Optimal change. And let's kind of pseudocode this out. So in the case that people haven't realized, this particular algorithm is the exact same thing as Roman numerals. It's completely identical in the sense that it's, if I were to, like the answer to 100 minus, I don't even know what the answer is, 100 minus 62, 13, 37, 87. So we all know, because we're human beings, it's 110, 120, 110, 15, 2 ones, 3 quarters, a dime, and 2 pennies. So we know that, like, because we are human beings, but how did we do that in our head? So I'm gonna, let's pseudocode this one out. So I'm gonna ignore that things that we were doing during week 1 and 2 for the easy wins, because we know we already created the class and it takes a method and all that kind of stuff. I'm gonna basically, I'm gonna calculate the change that you need to give out. Call it change. 2, I'm going to create a hash with bills, with like, we'll call this like denominations to values. 3, we're going to iterate over. Actually, let's just do those first two things just to give it. Actually, no, that's not code. Think twice and code once. I keep telling people that, and I want to jump right in. All right, so I'm going to create a change. I'm going to create change, like a change variable that with the change I need to give out. I'm going to create a hash of values. It's going to look a little something like maybe a $100 bill or something like that, and the value of it is going to be 100. And then I'll have like everyone forgot the 50. I did notice that. Most people forgot the 50. $50 bill does exist. I know it's not very popular, but they are in, and so on and so forth. So this is the idea of the hash that I'm going to go over. What I'm going to do is I'm going to iterate over each one of these for each key value pair. And then 3a. If the number, it looks like the value is greater than the change, move on to the next one. It's kind of like for us, when you do 3787, like if you're not going to start with a $100 bill because you know that's already larger. We can keep going down. So if the value is larger than the change, move on to the next one. If the value else, it looks like if I had 37 and I get down to 20, because that's the bill that's going to work, I'm going to divide 37 by 20 and see how many bills I get. Divide the change by the value and add it to an answer of some sort, which means we have to create an answer. Create an answer variable, that's string, for A and for B. Add it to the answer that many times. Subtract from change, and just keep going. Basically, it's like keep repeating until you reach 0. Does that kind of make sense to everyone? Like if I gave you, if it was 62 and I gave you $100, I think the change is, let me just write it here, 3787. So it's like you're not going to put $100 bills in, you're not going to put $50 bills in, but once you get to 20, you know that it's one $20 bill because 37 divided by 20 gives you 1. So I'm going to put one $20 bill in my answer, and then I'm going to and then I'm going to subtract it, which leaves me with 1787. And I keep repeating until I get down to $0. So I'm just going to kind of test this one out, 1 through 4. Create a change, create the change that you need called change. I think we can actually just put it up here because I know I need it everywhere. So I'm just going to have @change is equal to amount paid minus total bill. Again, you can just do this calculation because I know I'm going to need it. I know that I'm going to need to use change pretty much everywhere. So I'm just going to add it up here. All right, so I've done that. Create a hash with denominations to values. I mean, you can totally put it on the initialize if you want to, but just not to do that, let's just do denominations equals a large hash. We're going to have $100 bills that are going to be 100 bills going to 50, $20 bills, so on and so forth. $20, $10, $5, $1. We also have quarters. Quarters are worth 0.25. There's a dime, dome.
Is remote muted?
Remote is, they all muted themselves, but they are there. I mess something up? Oh, it's 05. Thank you. I've done number 1. I've done number 2. Now I'm going to create an answer variable that's a string. Maybe I'll create an answer equals some sort of large string. And I'm going to iterate over each key value pair. So denominations each do key and value. Key and value aren't the greatest. We could do key and value, but it looks like maybe it's a numerical value. And this is like some sort of word. Maybe denomination string or something. And we just want to keep it as descriptive as possible rather than just key and value. The key specifically talks about like the string that's going to be thrown as the answer, and the value specifically those numbers. So I'm going to iterate over each one. If the value is greater than the change, move on to the next one. We could do that. I think a little bit fancier is basically if change divided by numerical value is greater than 0. Because it's kind of like if you do 50 divided by 100 inside of Ruby speak programming, if I do 50 divided by 100, actually just gives me 0 because it's not gonna go in more than once. But if I did 50 divided by 40, I get 1.
Just a quick question. What happens if you do 50.0 divided by 1, or 50 divided by 100.0?
Great question. Gives you, once you add on this dot something, it becomes a float instead of an integer. Yeah, once you get to this point, it's like it becomes a float rather than an integer. So we probably will need to account for this a little bit later. But I think for right now, since you're dealing with like just round whole numbers, we can deal with that pretty easily. So if the change divided by the numerical value is greater than 0, meaning it's this first thing here, if it's not this first thing, we're going to divide the change by the value, add it to the answer, and then keep reaching until you reach 0. Let's do, I know that I'm going to need to do change minus equals numerical value times, just say number of times divisible equals change divided by numerical value. If number of times divisible is greater than 0, I'm going to multiply the, and I'm going to do this. I am not sure how to add it to my answer. How do I add it? How do I add my denomination string to my answer?
You can use a shovel. You basically use a shovel method.
I could do a shovel method, but I do have a string, so I can't shovel into. Can I shovel into a string? Let's find out. A shovel B. A B. I could shovel. Okay, we can shovel. Answer shovel denomination string. Something seems wrong here. I'm not taking into account all of my. What's that?
Your R specs.
No, I'm not. I'm not keeping in. You know how I had to like pluralize everything and all that kind of stuff.
Yeah.
How do I get that in there?
You can do a conditionals. You can do a conditional statement.
Okay.
If number of times divisible is greater than 1,
Okay.
it would be a plural, so you want to put an S.
Okay.
You do an interpolation.
Sure. That's probably fair. Let's comment this out, and let's get this first little bit here. First things first, we're going to do the optimal change for an item that costs, what is this? Total bill with an amount paid of, I can interpolate again, amount paid is something. So if the number of times is greater than 0, meaning it actually goes in, well, you said have another if statement in here, right? So if number of times divisible is greater than 1, which means it's more than one of them, I'm going to answer plus, I'm going to do plus equals number of times divisible, maybe the denomination string. Else, we go dealing with singular, so
Pennies. IES.
pennies is IES. Let's. Do you want to do another one final? Oh gosh, and they're gonna have another if nested if in here, right?
Yeah.
Let's just see what we get. How's that? Like, I think this is a decent place for us to start. Again, what I've done is my object, I've created a hash of all the things that are possible, and I've created this giant loop that's basically says like I'm going to iterate over each one of these key value pairs. If it's divisible, meaning like it's like if I have 37 and 20, like I can finally actually do something with it. And I'm just adding on to the string and removing from change. Let's see if this does anything. Let's see what we get. RSpec. All right. It says there's an undefined method minus for nil class for optimal change line 39. Line 39, there's a broken thing with change.
Oh, it's only reading change, it's not
Okay.
changing.
Yep. So even though I've created at change on line 12, made it an adder reader, I'm trying to subtract something that you can't subtract for because it's just reading right now. So I could make it a writer as well. Still an issue.
Do we make it an accessor?
We could make it an accessor, but that's not solving the
It's not
issue
gonna
right
solve
now.
the issue.
So where's change? Change minus equals.
Just make it an instance variable, maybe.
Maybe. Let's just throw an at in front of it for now and let's just see what happens. Ooh. So we got something. It's not happy with me though. So let's try to make that an accessor, like you said. All right, the accessor did make a difference. So what we got was the optimal, we expected to see the optimal change for an item that cost this, and instead we got this.
Hey, John,
Oops.
could it be the comma after the penny in the hash declaration?
Let's find out. So we can close that one out, and we'll run it one more time. Fortunately, it is not that, but that's a good call. I appreciate you finding that pretty quickly.
There's another comment there after the answers hash. Find the answers on calculation.
Can you take out the at on change and run it again now that you made it an accessor?
Sure.
I just want to see what happens.
Oh, nope. We go back to it being broken. So you can't subtract, so the optimal change. Kind of wondering why I can't do it here. Let's put a pry, find out. Here we are. Let's take a look what changes. Oops. Change is nothing, but at change is 3787. Is change available at this point? changes nothing. I don't know why that is. That changes that, but I've made an accessor off the top.
It's probably gonna be an instance variable as well.
Yeah, I am not going to look too much into this right now. I'm just going to put an at in the front, but I'm not sure why that is. Another option that I can do, just to make things a little bit easier, I could just do change equals amount paid minus total bill. Directly in here, get rid of this altogether, and get rid of that. Make things a little bit simpler for now. See what we get. All right, so we're back to where we were before. We expected this giant string, and instead we got this strange hash of stuff. Any ideas why that's happening? Like, I thought I was updating the answer, and then instead I get this giant hash out. I'm not really sure why that is.
Your inputs denomination string and value.
Those are good. So
I think it may be that the dot each.
Yep.
Is not creating another object.
correct. No, it is. But the issue with what's happening here is I'm running denominations dot each. The dot each actually returns something. That returns something is the original.
Well, you need an each with index?
Nope, not each with index.
Okay.
I just need to return answer down here.
Oh, yeah.
Yeah. So denominations dot each will return anything dot each will return the original thing that you're iterating over, and not the actual answer. So because that was the last thing that came out, like that was the last piece of code that was run, the thing that came out was this giant hash. So if I run this now, I'll get something a little bit different. All right, so it looks a little bit different. So I expected to see this. The optimal change for an item that costs $62.13 with an amount paid of $100 is one $100 bill and then nothing else. That's very bad. One $100 bill is you already know that's incorrect. Okay. If the number of times divisible is greater than 0, let's put a pry in here. I'm not really sure why things are broken.
I think it's the integer division. Might need to do
It's possible. You could be 100% could be right on that. That's why I said I don't know. I'm not going to guess based off of this. I just want to mathematics behind it.
I was working on it for about 3-4 hours. So.
All right. So this is the first time through. My denomination string is a $100 bill. The numerical value is 100. So let's take a look at the number of times divisible. This should give me 0. Okay, so change divided by 100 is that. So it looks like the number of times divisible is greater than 0. So it looks like we probably need to floor something. Like round down.
We'll just say greater or equal 1. Wouldn't that do it? Oh, no, because then you get 1.3.
Yep. So let's see if this makes a difference. I've done one small change. Maybe something will look a little different as a result of it. Bam. Okay, we got something different. We got a little bit further than we thought. So we got one. Yep. We got one $120 bill, one $10 bill, one $5 bill, two $1 bills, 3 quarters, 1 dime, and 2 pennies. But I have 1 penny. So we haven't taken into account for pennies. The number of times is greater than 1. Else something cool. So we are good until we reach the pennies. So we have to do what Sharif said. We have to deal with pennies at this point. So where's that if statement going to go? Like basically if we are dealing with pennies.
Oh, and that's just basically put this hard code in.
Could just hard code it in there. I like it. I'm not opposed to it. Where?
Probably between line 36 and 37.
Yep. I agree with you on that one. if the denomination string is equal to penny. I'm going to do something. Otherwise, I'm going to do this. Gosh. Number of times divisible pennies.
You gotta tell it somewhere that has more than one penny. Right?
What's that? And the number of times that it goes in.
The only issue with this is probably gonna be the placement of pennies within the end. So we gotta probably move pennies down to the end of the string.
Maybe. Maybe let's run the test. That's why we have the test now, because we know exactly what the output's going to be, so we can just run it as many times. That's the benefit of doing it with the test-driven development. Bam, let's see what we've got. It doesn't pass. So we got the optimal change for an item that costs blah, blah, blah is this, and we have everything except for the penny. Okay, so we got 1 penny. That's no good.
Oh, so there's a mathematical error on pennies as well.
Okay.
If you're owed 2 cents, it does math. It gives you a really large decimal place.
Okay.
So it says like I owe you 1.00009.
Is that right?
Yeah. So you just got stealing that for the pennies change. So that'll make it 2, but you're still the string.
Okay. Let's throw this here, and let's throw a binding bracket. I'm going to be entering exit a whole bunch of times. I'm going to run through it. The first time I'm talking about, let's take a look at denomination string. $100 bill. Second time through, $50 bill. Third time through, $20 bill. Okay, so I should be hitting this 36 block at this point. Cool. Exit. Dealing with the $10 bill. Dealing with the $10 bill. $5 bill. $5 bill. $1 bill. Dime. Full. Penny. Now we're on pennies. So the number of, let's say what change do we have left? We have 0.1. Oh crap, that's no good. That's where it blows up. You're saying, right? Because this is only 1 penny because it's not rounding.
Integer instead of .4.
We could parse the integer. We could just do. I think that's it. We'll find out. So the issue, what we were finding is why we were getting 1 penny earlier, is due largely to the fact that for some reason it's when you keep subtracting decimals from decimals from decimals, you're getting like very, very exact numbers, and I just want to round it to 2 decimal places. So I'm going to exit out of everything. I think that round will do things. Nope, it's no good.
I think we probably shouldn't use decimal points at all in our declaration of denominations. Just basically multiply by 100.
You want to multiply everything by 100?
Yeah.
It's not a bad idea.
We don't deal with any decimal points at all.
That's one idea. So I just do 100, adding 2 zeros to the end.
Why is that?
What's that?
Why is that happening?
Why is it happening? I don't know off the top of my head. I can figure it out, but I want to be respectful of time, considering we have more stuff to go through. We also have to go through Sudoku, which is going to take a while. Okay. $100 bill. Okay. We're closer a little bit earlier.
Oh, we didn't do any. We still doing it to the division. We didn't do any floor method.
This thing?
Yeah.
We got somewhere. is 1/4, 1 dime, and 2 pennies. That's largely incorrect. Change. Oh, I didn't. Change is this. We got a little bit closer. One $20 bill, one $10 bill, one $5 bill, two $1 bills, 3/4, 1 dime, and 1 penny. We're back to this. Let's just put a binding price here. Let's see what happens. We're going to skip over everything until we get to the penny. Doesn't even get to the penny.
Yeah, we were really close. Like if you, at that one point when we had that rounding error for pennies, all we had to do was fix that rounding thing. And we were kind of
I think you're correct on that one. It's 1/4. We didn't even get the pennies. Okay.
I'm not even.
Go back. Let's go back to the point where we didn't do this. Take a quick break. Use the restroom or something. And then we'll come back. We'll finish this.
Are we scheduling our one-on-ones again?
I'm around. I mean, my hope is to do it today. It's the 2 of you guys.
Okay.
But it depends on. We told me about this one pretty quick. I'll be here for it.
Penny answer plus and number is with pennies, right? But I don't understand this conditional statement. If the nomination string is equal to pennies, so then we start dealing with an answer plus and a number of pennies is greater than 1. There's an issue. This is the issue we need to do. That's the issue, line 33. And also, we can just get rid of dealing with decimal points by just making all these integers. And then do a parse integer division as opposed to the floor. That'll make it work. I did a little bit differently.
Okay.
Instead of
I think it's like one tiny thing.
yeah. I did the .4 method, but the only thing is that for the
one small little issue.
Oh, okay, got it.
I've never done that before.
Let's do it each time. It's visible 0.
So can we go over this binding prod thing? Because I try to use it when I'm like, well, it never, like I
Sure.
see how you're doing it. It's just, it's kind of like TDD.
Mm-hmm.
So I know it's helpful. It's a helpful tool, but I'm kind of having a hard time understanding how it actually works.
Sure. So pry is a library, which is why I have to require it on line 5. Like it's a Ruby gem they get to install on your computer. Once it's installed, you just run require pry on line 5, which brings that library into this file. And the way that you use it is everywhere that you put a binding pry, it stops. It just fully stops at that point. Like it'll, as of right now, my code is fully stopped at line 34. It won't execute until I tell it what to do. So because I'm here at line 34, I can look around and I'm like, all right, let's talk about which denomination string am I talking about? All right, I'm at the $20 bill. I'm frozen at a certain point in time, right? I'm frozen at the numerical value is 20. The denomination string is this. It goes into it. This is correct. It goes into it one time. So it'll fully stop here until I type the keyword exit, and it'll keep running until it hits the next binding pry. So the next time through, since I'm doing a loop, I know that the denomination string is going to be a $10 bill, and the numerical value is going to be 10, like just the number 10. Because I know it's going over and over in a loop, I can just hit exit and then hit the right spot. Here, this is a $5 bill, $1 bill, quarter, dime, nickel, and if I'm right, this is a nickel. One more time. Denomination string is going to be a penny. The numerical value of that is 0.001. Let's take a look at what the change is. It's that. So the change itself is still this one giant number rather than 2 cents, which is an issue.
Now, when you put 2, you did it to round to 2 decimal places?
I did, but I think the issue is...
Put it like 5?
No, I don't think it's that. I think I can subtract it, and I'm going to do change dot equals change dot round. Because I think what's happening is the change itself is not actually going down, but it is becoming like a strangely large, like, as you can see here, change is not 2 cents, it's 0.1999, like all of this kind of stuff. So I need to round that. That's my guess.
You don't give somebody back 0.019 pennies.
Exactly, yeah, you give them back 2 pennies. So I'm going to exit with a bang. We'll exit fully out of the entire program. I go here. I have a $100 bill, 50, 20, 10, 5, 1, quarter. Let's just check where we are. Quarter, dime, nickel. I should be at the nickel. I am. Let's take a look at what changes. Change is 0.02. So I exit. Now it passes. Yeah. So it's just that small little rounding thing here at the bottom.
Just a quick question. Could we? Is there a possibility that doing a parts integer instead of floor, perhaps maybe that would or parsing it into that division?
We could. I just think that floor is a little bit easier because dot floor is a method built into every integer where you can just, like, if you have a number like a decimal or something like that, you can just do dot floor and then it rounds down.
Okay.
Yeah. Parsin could work if you would like to use that. It's a little bit more challenging. I figured just dot floor just rounds down, and then that makes things easier for people.
Yeah, I think I just hard coded it into my spec 1 penny in order to get it to pass. That wasn't working.
All right. Well, so again, we've written the tests, we've written the code. Now, is there anywhere we can refactor? Probably, but due to the sake of time, I'm not going to go over that. So what I'll do here is I'm going to clean this up a little bit. I will leave this here, and let me just push this up so people have like a reference point of like what the answer could be. I'm going to check out a branch, check out B. I'll show this John's branch. Its status, what have I changed? It looks like I've modified the optimal change file, and I've added a brand new one. So I could do git add with this and git add of this, or I can just combine the two and do git add space dot, which means add everything that has been changed. So I do git status. Now I have a modified file and a new file. might make myself a nice little commit message. Maybe this is John's solution to assessment 1. And hit push to John's branch. I'll run back over here to the assessment 1, create a pull request. I'm comparing it from John's branch and pulling it into master here. So now if you need to see what my potential solution is, you can just come over here and take a look. All right, let's talk about Sudoku. So tell me how your first group project went. Without any sort of training from us, we just threw you in the deep end and just said, do a group project. How did that work out for you? What were some good things and what were some bad things?
So we largely solved the puzzle, but basically I think most of the problem was that in the initial strategizing of how we were going to tackle this issue of solving the puzzle, I wasn't there. Okay. So the strategy that I typically use to solve Sudoku,
yeah. That's correct, Sudoku.
Okay. Is to like do it a different way, but basically, my group, they solve it in a different. Well, I would say Raymond solves it in a different way. His sister is really good at solving puzzles. So the way that he was solving was the tick mark or whatever. But they basically came up with like a really nice algorithm. But yeah, I think if I was there, I would have been able to understand better what that strategy was. So I've never used that strategy ever.
Sure. So Sudoku is a very, very difficult challenge. And to throw people into like a group setting that they haven't worked on before, it's kind of done purposely just to kind of see like
it's already a hard puzzle to solve. So we come up with an algorithm to solve something that's already hard to solve.
Yep. And then on top of that, you still have the added complexity of I've never worked on a large group of 4 before. So we have so one thing is kind of like make sure everyone's on the same page seems to be a lesson. What other lessons did you learn?
Also, since it was we had to use a lot of concepts and methods that we've never touched before.
Sure.
In order to do what we wanted it to do. So we were messing with like symbols, helper methods, and stuff like that we've never touched. So it was like taking longer to try to access if we didn't know how to access certain things. We spent a lot of hours just on figuring out the new concepts we learned.
Sure. So. Yeah, definitely. Again, I don't know if how people feel about that. I don't know if you feel like cheated, like Johnny didn't teach us half of this stuff, and then now we have to use it. We can't teach everything. It's not possible. There's just not enough time in the world. So some of it, most of programming is just like, what can you learn on your own? Like we'll teach you the base concepts that you're going to need, but a lot of it is, what can I find from Google? Can I try this out? How is it working on a team of 4? Like in terms of how did you work out the logistics? You know, of like, what time are we getting here? What time are we leaving? Are we doing pairing and things like that? Like we haven't talked about anything related to teams at all. So how did you, in your first group project, deal with that?
Whatever you wanted, like everybody was willing to.
Okay.
It didn't matter if you weren't able to come in a certain day.
Okay.
Pretty much everybody was able to come in and be pretty reachable.
It's a democratic process. Well, I'm coming in at this time. If you can come in, please do, kind of thing. And it seemed like,
And if not,
yeah, that's fair. Remote, how did it work out for you when you were dealing with, when you had to work with, remote people, like on a fully distributed team? I'm curious.
For me, I felt like it was a learning lesson in communication.
How so?
Well, because I'm on a different time zone, there has to be very clear communication as to what was completed and what wasn't, and what are the expectations, because I can't read minds.
Right. Okay. How did you how did your team and you communicate about that when you were like, because you're obviously sleeping at certain times when they're working. So how did that work out?
Well, it didn't really. I mentioned it last night, but by that point, you know, it was Sunday night for me and Sunday afternoon for them. And, you know, so basically the whole weekend was over.
Okay. So it seems like you probably want to, in the future when we do like these types of group projects, it seems like you might want to start off at this is the idea behind, like the idea behind this is there's a concept in Agile called this daily stand-up. And the daily stand-up, you kind of learn about, you're like, okay, everyone stands up at a certain time and they talk about what you do yesterday, what you do today, what are you stuck on? Like, it seems like it seems kind of ridiculous, you know, it's kind of like, I'm just coming to work. But when you're dealing with distributed teams, when you're dealing with people who are like, I have a doctor's appointment, or I have, you know, I'm on a different time zone, or something like that. This becomes very important when people are coming in at different points, or like, well, some people's day started at 9 a.m. where other people's day starts at 11. You know, so that daily stand-up is incredibly important just to catch up everyone just to know where they're at. So I hope you didn't. You know, when I did Sudoku for the first time, it was at Dev Bootcamp. It was the end of week 1, and I got into a fight with. I almost punched someone in the face. I was a very angry 24-year-old. But this one, we were not clear on the instructions going back and forth. Right, we were not clear on how to really solve it. So one person said, like, "Can you write a method for me that does X, Y, Z?" And I was like, "Sure." So I did that. I didn't really clarify too much. He didn't clarify too much. It was a much older person who had worked who was like in it, you know, who had worked in the industry for like 20 years, but wanted to make a shift over. So I trusted him that he knew what he was doing. I went off on my own for about 3 hours, incredibly frustrated. I finished it and I brought it back. And he basically says, like, this is worthless. Like what, you didn't even like remotely listen to what I had to say. You know, this is not solving what we wanted to. So, you know something's going to go wrong when I stand up really fast and he stands up really fast. And at one point, like, my whole group was like, let's go somewhere else, you know. So I'm glad it did not come down to that. You know, I think everyone had more patience than, you know, younger version of me had. So I'm glad that worked out fairly well. But yeah, working into groups is extraordinarily difficult. We're going to have more practice with it in the coming weeks. But, you know, this was as much of a challenge on how to work in a team and communicate effectively as it was this particular challenge. How do people feel? Did they have fully solved, like, did you solve all 50 of them? All 50 challenges? No, from the in-person. Remote, did you solve all 50 of them?
No.
Okay. With that, let me quickly go over, I have my solution up here. It's up here under John's branch. So I'm going to clone this down real quick and kind of go through it. I'm not going to like try to solve it. It's already solved. I'll just kind of go over it. Throw this in the trash, throw this in the trash. All right. Go over to my desktop. This is how basically I go through all of your code. So I go here, I clone it down, change into Sudoku, open it in Sublime. And as of right now, you can kind of see Sudoku has really nothing inside of here. But I can check out, without a dash B, John's branch. Without dash B, I'm just saying I'm moving to this branch that already exists. If I do git check out John's branch, because I know that's an existing branch, and I go over, magic. On my computer, I have all of the code that you need. So that one little trick is kind of like I go here onto pull requests. If you like, let's put it this way. Please do not. Oh, this actually leads into another thing I want to talk about. When an employer goes on your particular GitHub page, they can see all of these green dots, and these green dots are great because they say how much stuff has this person done in 2018. Well, 2018 looks like, you know, there was quite a bit of stuff that they were doing. 2017 looked a little different. 2016, when I was working as a dev, you can kind of see a very strict Monday through Friday, like this is where I'm committing code. 2015, more of the same thing over here. I want to make sure that when I go to Raymond's page, that when I look down here, I see lots of green. You know, I see that this person knows how to use Git. The way that you get Git credit is by opening pull requests on the master branch, off of the master branch. So that means please do not fork anymore. If you fork, you don't get, you'd still get credit, but it makes it a little bit more difficult for us. You get credit if you open a pull request. So just clone it down, check out a new branch and push up and then create a pull request. The moment you create a pull request, you get credit. On top of that, when you go here on your main page and you see contribution settings, click this public and private contributions so that you get all the credit for whenever you open a pull request here in here at Code Platoon. Because we are a private organization, so like you will get credit if you click this one on the bottom. So again, please don't fork anymore, and click this and hit the public and private contributions. Sudoku's hard. Sudoku, Ruby way Sudoku is very, very difficult. So I decided to use recursion just because it calls for less code. So let's just see if this works first. So I'm going to list everything out. I'm going to run rspec Sudoku spec.rb, and it's going to go through each one. Hopefully it'll solve all 50 of them. And as that's running, I can just kind of show you the spec that I wrote. So all I need to do is just have this hashtag solve. Again, this describe block is describing a particular method. And I'm running through a whole bunch of code that I need to go through first in order to solve each thing. So we're going to talk about this tomorrow, but I'm going to read using the CSV library all of the inputs. If you can see, like this is just a giant list of inputs. So what I'm going to do is I'm going to read each one. And when I get it, it's a multi-dimensional array, so I'm going to flatten it, and I get each game string. Like each one of these is going to be saved as the variable game string. I'm going to create a game. I'm going to try to solve the game, and then I expect there to be basically like no blank spaces, no zeros or anything like that. And if all goes well, this is still solving on this side. It's starting to get a little bit more difficult for the computer to go through because it's getting to the harder ones. But it still looks like it's going through. This is the original. Hopefully this will solve, and then you'll see the printed out fully finished version right there. And so I have 50 examples and 0 failures. I just want to quickly go over what we have here. So I have this class Sudoku. I'm going to initialize it with a board string, kind of like down here. I have r equals Sudoku.new. I pass in a board string. I'm going to solve the board, and I'm going to have the board print out. So when I initialize it, I set board string as a reader, and I just print the board. So let's just take a look if I were just to run this particular thing. So if I run Ruby, just Sudoku.rb, it prints out the original board that you start with in like a specific board fashion, and then afterwards it solves it, and then I tell it to print again, and it looks like this. So I've left as many comments as I could just to make things a little bit easier. So first things first, initialize with a board string, print the board out. When the print board is down here, and the idea behind why I have so many methods in here is I want each method to do exactly one thing. I want very, very small methods, because if I have a method that does 3 things, I have 3 times as much code to look through rather than just 1 time the amount of code. So I have an output string, like kind of like what we were doing with answer usually. What I've done is I've created a variable to begin with that starts at 1 so that you can count like a human being rather than like a computer. After each 9x3 section, 9x3, I create a bunch of dashes over here just so it's more easily read. If you have a 0 to begin with, just kind of like over here, I'm just going to replace it with 3 spaces. So as you can see, I have a 0 to begin with, so it's just 3 space 0, and then 3 spaces, and then 0 again, which is just 3 spaces. So it's just like it's a visualization to see where I get started. I'm going to put pipes after every 3rd and 6th character. So every 3-ish characters, I put a pipe. After every 6 characters, I put another pipe. And then I put a new line after every 9th character so that it kind of goes into the next to the next realm and the next realm, and then 27. And all I'm doing there is I get the board string that I start with, and I'm just printing it out in a nice, easy to use fashion. Now this solve one is a little bit more tricky. All right, basically, I'm trying to, what's happening here is if the board string index 0 equals nil, basically, if there are no zeros on the board, then we're fully solved and we're finished. We don't have to do any more. If there's no zeros on the board, we can just return true and print out the board string. Otherwise, we're going to set the next missing numbers index, like that's the missing number, equal to that board string index 0. So it's for us just to kind of get started. If I gave you this giant string, I did index of 0. It should be 1, 0, 1. So if I change this to do 3, 1, 0, it gives me 2 because the next appearance of the string 0 happens at 0, 1, 2. If I replace that one with 1, it'll go to 4, 0, 1, 2, 3, 4. So it's just finding the next particular instance of a 0. All right, so basically there are 9 moves you can make. Just the numbers 1 through 9, basically. I'm going to, first things first, the idea behind this whole thing is I'm going to brute force every single number. I'm going to set the missing number as 1 and test it against every single check that I have. And if that's all good, then we can just put 1 in there. We're good to go. If it's no good, then I will move on to the next one, 2, and then brute force it and check through everything again, 3, and keep going over and over again. So I'm going to set the board string at the next missing number, which is that 0. I'm going to set it to like 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just going to call legitimate board on that to see if this is a good thing. So legitimate board does a few checks. If it's not a legitimate row, if it's not a legitimate column, if it's not a legitimate grid, then it's not legitimate. It has to pass all of these in order to be true. It has to be legitimate row, column, and grid in order to be a legitimate move.
Quick question. So you were getting something like maybe outside of, you would be getting values if you were not to add that check there, you would be getting values outside of the array or outside of.
So I'm only using a string. I actually did not use arrays for this one. Yeah, you could do this in an array format as well, but the idea is still the same. Like find the zeros, because you need to test 1 through 9 for all of those, and then see if it's a legitimate row. Like if I go all the way across, like are there any repeats? If I go in a column, is there any repeats? In a grid, is there any repeats? So that's my legitimate row, column, and grid. The math on these is kind of disgusting, so I'm just going to kind of leave it to you to read. But essentially what you're going to do is you're going to create a row out of it, create the column based on the number you're passing in, and create a grid. And if it's valid, then you're good to go. If it's not valid, I'm going to return false. And then that's going to bubble back up to this legitimate board thing. So if any of these return false, then the whole thing is no good. And you move on to the next number.
What are you doing with shift? Shift amount equals row times.
All right, so this one's a little bit confusing. So if I give you a number, if I pass in a number, let's say it's like the one I'm testing is 4, right? And the index of the number is like 28, right? That's the 28th number inside the string.
Right.
I have to find the row that one is on. So if I do 28 divided by 9, that gives me the 3rd row, right? 28 divided by 9 gives me 3, right? So I know I'm dealing with something on the 3rd row of Sudoku, right?
Oh.
And then when I do that times 9, I get the exact space, the exact index that I'm talking about.
Okay.
So your shift amount, I'm sorry, bro, you were done with your portion. Okay. So the shift amount, basically you take in chunks.
Yep.
Okay.
Yeah, just small little chunks.
That's again.
Yep. And then I do that for a row. I do that for the column. they're all a little bit different. A row you have to check a certain way. A column you have to check a specific way, and a grid you have to check in a specific way as well. So the idea behind it is I have all these checks. I basically see if it's a valid, So if the index that you're passing in is not the index of the number, and the number is equal to, if it's valid, basically if it's valid, that's the check that's going on here in block 77. The confusing part is this thing right here. So basically, if it's a legitimate board, then we're going to recursively call the method again with the next missing number. So it's kind of like if everything is good, then we'll move on to the next, then we'll call solve again. Because it's kind of like if I did this like 3002 thing, like the first 0 is going to be here. Let's say that number is like 1. Then I'm going to call solve again. That's that recursive call. And I'm going to find the next possible 0. And I'm going to kind of like keep solving over and over again until there's nothing left. Then I just return true all the way back up. If we would have finished our method, it would have been way faster, but we're like 70% done. So it's like it can't finish, but it would be way faster. If it works? If it works. Yeah. If they get it to work.
But keep in mind, we didn't just go through one puzzle.
Yeah, but brute forcing every single one.
Brute forcing every single one is not a smart idea. Yeah, at one point, you do have to guess. That is the issue with these things down here. The difference between like this particular puzzle up here and this particular puzzle down here is the number of zeros. Yeah. And you have to guess at one point. Like you have to actually go down a brute force path. You have to make an educated guess, but yeah. And then the final thing here is if you go through all the possible numbers 1 through 9 and you can't get an answer, that means you have to go back out one level, change to the like 1 to 2, and then go through 9 possibilities again. And you have to keep doing that over and over again. So this is definitely not the best way to solve it. It's just the fewest lines of code that I needed to solve it.
The way Jonathan and Sharif and
who's John?
Raymond.
Raymond.
And Sharif.
Because we're both Asian, right?
No, negative. They basically what they did though was their method was to look at each cell and to get intel on the actual cell, and then from that to compare that basically a hash value. And so by doing that, really, I think we wouldn't have to actually continuously recursively go over the cell. It would actually be solving for each time you go through it. Actually, we'd really be placing the correct number. So it was
no, that's definitely right.
Kind of mind-boggling at first with some of the syntax that was being used, some of the methods.
Yeah.
Yeah, it escalated pretty quick. It
got hairy pretty quick.
Yeah, absolutely.
Yeah. So this solution is up for you. So if you want to take a look, you just go to John's solution to Sudoku. This one of these pull requests. If you want to take a look, a little bit deeper dive into it, you can look over here. Okay, so I know that we have one-on-ones for the in-person students starting right now. Rod, is that correct?
Give me 10 minutes.
10 minutes. Okay. What we will cover today is a couple things. We essentially covered this already. Let's jump to week 3, day 1. We're just going to be covering different types of variables. And then we're going to be talking about instantiating objects with hashes. So hopefully I can get through this relatively quickly. Let's talk about this. All this variable. Sure. All right. Inside of Ruby, there are many different types of variables. So let's just call this, I'll call this ghost.rb. All right. There are 5 different types of variables, and they look a little something like this. One is a local variable, It begins with A through Z or an underscore, and it's only available within its immediate scope. Like local variables are they're the bread and butter of all Ruby programming and all programming in general. Local variables to your file, to your methods, to your classes, like these are the bread and butter. Then we talk about instance variables. Those are specific to that instance of a class. So you can think of it in real life, like every single person here is an instance of the class person, if we were all created from the factory of person. Each person has an instance variable called name, but it's specific to each instance. So it's kind of like when I ask myself for my name is Jonathan. I know that because I'm an instance of person, and my instance variable of name is going to be Jonathan. And each one of you has your own individual name as well. Class variables is with a double @ in the front. It's available everywhere, anywhere in a specific class in all instances. So every single instance, if you create like a class person, and then you give it a class variable, every single person has access to that variable. You generally want to avoid this. When you're dealing with globals, it's a $ in the front. It's available everywhere, like literally everywhere. Inside your class, inside of other classes, the moment you declare it, it's available in everything for the rest of your application. And then finally, constants are all caps. It's available within the scope of the definition. It's generally something that doesn't change. Force of gravity, how large the Earth is or something like that. I guess that could be a debate for another time.
Excuse me, with constants, there's a dot freeze method.
Yep.
I think, can you touch on that a little bit? Just like when would be a good time to use a dot freeze?
Yep. So so let's just call it like force of gravity. You can kind of see how it turned like this. I can call force of gravity dot freeze, which means that at this particular point, no one can ever change force of gravity. Like you can't add to it, you can't make a difference. That dot freeze is just basically saying like freeze it at this particular point in time. We're going to just keep it like that. All right, so let's quickly talk through all of these variables. So local variables, again, they start with lowercase letters or underscores. I'll just call this my name. And they're only available within its block of initialization. They're going to raise an error if you call it before they're created. And these are used very often. So my name is John. And if I have a method name, it said print my name. This is totally legitimate. I've created a local variable. It's local. At this point, my name is local to ghost.rb. And I can call print name over here. So we do print name. I just run Ruby on this. It blows up. It says local undefined local variable or method my name. What's happened here? So again, I created a local variable called my name, which is equal to John. I have a print name, and it says print my name. And then when I called that method, it says that this particular my name was not defined. There's an issue here.
It's expecting a parameter.
It's expecting a parameter. I could do that, but mostly this particular method here is calling something called my name, which doesn't exist. If I do my name equals not John out of here, what would my output be? So I have my name equals John on line 1, my name equals not John on line 4, and I'm printing my name. So when I call this entire method, what do you think is going to come out? Not John. Find out. Yep, it's right there. It says not John. Let's go to puts instead. Not John. Why is that? Why is that happening?
String not John is within the scope.
Yep. Yeah. Local variables are the bread and butter of all programming. So it's available within the scope that you have. So if I did, because even though I've written my name is equal to John on line 1, I've overwritten it because this is the immediate scope that print name cares about. Everything between 3 and 6 is just kind of enclosed, and the local variable my name is something different at this particular point. So these are local variables. These are used the most often. let's create something really quick. So we have a class called Ghost. When I created a new ghost, I'm going to pass in a name, like the name variable. I'm going to set that equal to @name and use it here. So all of the things that start with an @ symbol in the front are instance variables. Instance variables are available to the object of the initialization. So if I use g equals ghost.new, and I'll make this, sure, I'll make myself a ghost as well. Why not? Like I have this particular variable called g has access to name. So let me just do p g.name. Let's see if this works. The name is going to be John. Again, instance variables, it's kind of like if I want to use if I want to use what I pass in name var anywhere else, I need to put the @ symbol in the front. So if I were to say like def say hello, this ghost can say hi to you and say, hi, I am name. So instance variables, local variables, I think most people are fairly comfortable with that. You've been using it for about a week now. Then there are things called class variables. Class variables begin with an @ 2 ats in the front. And class variables are available to every instance of class. So whenever you create a new ghost, you know, if you create 50 million ghosts, it's going to say they know that the number of ghosts in the world is equal to 0. So you generally want to avoid these, because if I wanted to do like, let's just say, let's get rid of this. If I have the class ghosts, there's a class variable called ghosts in the world equal to 0. So when I initialize the class, I'm going to increase the number of ghosts in the world, and then I'm going to set the name equal to the same thing. How many ghosts are there? So let's just do g dot how many ghosts. Maybe 1. I do g equals b2 equals ghost.new. I'm going to make Mike a ghost in the back. Sorry, Mike, you're also a ghost like me. Sure. Let me just make sure if this works. 1, 2, and I go back to how many ghosts are there in the world? It goes 1, 2, 2. So the issue with class variables is that it's not especially reliable data. And the reason behind that is because it's available to every particular instance of the class ghost. Like if you're relying on something to be constant in your particular instance of ghost, and like you should not be able to alter something for all of mankind, correct? Like you as one person should not be able to alter something for all of mankind. Like I've decided that every person's going to have 3 eyes, you know, and I'm the president of the world or something like that. You can, the equivalent of this is basically saying the president of the world can say every single person now has 3 eyes, and then all of a sudden you magically grow a 3rd eye right in the middle of your forehead, right? Like that's not something that you want to do. You don't want to have that type of access. That's the idea of why I don't want to use ghosts, like the class variables. Aaron.
So I was doing a little reading up on the class variables because I was really getters and setters. It's kind of like one of those setter type things.
It kind of is like a getter and setter. Getter and setters are specific, like, so getters are this adder reader here. Setters are the adder writer. In the case that your ghost decides to take on a new name when they die. So getters and setters are really specific for instance variables, but you can do the same thing with class variables. Yeah.
Another question: can I actually just print class dot variable ever?
Like if I do ghost dot ghost in the world.
Yeah. Yes.
I don't know. Let's find out. Just do ghost.new.ghosts in the world like that, or do you want like directly on the cast, like literally ghost.ghosts in the world? We'll find out. It'll blow up. It says there's an undefined method ghosts in the world for the ghost class. So it's like there are
So it's
class.
looking for a method.
It's looking for a method on the class and not on the instance of the class.
Maybe if we initialize it with new.
Yeah, but then that's exactly what that's the same thing you were asking earlier. Get to the name. Errata ghost too. Ghosts in the world. There's an undefined method, ghosts in the world.
Oh, it needs to add.
What's that?
Does it need to add?
I don't believe so. I think you need to set this equal to to a variable and then call dot ghosts on the world on that particular instance. And finally, just to kind of finally, we have something called global variables. These global variables start with the $sign in the front. They're available to the entire application. So not only is this like, this is not the president of the world saying everyone's going to have 3 eyes. I'm going to set the class variable, and then everyone grows a 3rd eye. Like you wake up in the morning, you're like talking with your boss, and then all of a sudden a 3rd eye grows on both of your foreheads. This is a global, meaning that it's available to the entire application. You don't want to use these because these are extraordinarily dangerous. So if I set a like dead equal to true, which is obviously true for all ghosts, and I make it a global variable, basically I'm able to read it inside of here. If I created another file called notghost.rb, and I require relative of ghost, like I also class not ghost. Like, let's put this real quick. So if I have a class called ghosts, and inside of there I set dead equal to true, and I create another class called not ghost, and I call is dead ? And it reads from this global variable, like this particular file also has access to this $dead global variable, which is not something that you want. You don't want to have availability and like knowledge in other places. You want to encapsulate as much as you can.
So right there, if you printed it, it would say not ghost is dead. But what if you put an instance or local variable within that file? Which one would win now?
So these are just 2 different types of files. So if 2 different types of variables. So if I had def initialize and at is dead equals
No.
true.
So on this one, on not ghost, you would be saying, okay, this guy's not dead. So you would say this not dead. For this program, it is dead. Ghosts are dead. But if you put like an instance variable, not dead, or a local variable, not dead, what would win? The global or the?
It depends on what you call. Like, so that's what I was trying to demonstrate earlier. Like these again are like these are 3 different types of variables. So when you call $dead, it literally looks for $dead. If you look for like, if I do dead equals beer or something like that, this is a local variable, so I'm only calling local variable. So it depends on what's in the front.
If you want to read up on it, it's called overriding.
Okay.
Can we do a .id? Let's see where it is in memory on that global variable. I don't know if there's like some type of method that we get space its location in memory.
Let's do that afterwards because I'm running a little behind. Okay, so Rod, you want to run the one-on-ones?
No, you need another 10 minutes.
Okay, now you need another 10 minutes. Okay, that's fine. All right, so
All right, let's just make it 11 o'clock.
11 o'clock, fantastic. All right, I will be definitely done by 11 o'clock. I want to do. Okay, so we've covered local variables, instance variables, class variables, and global variables. Main thing just to say, use instance and local variables 99.99% of the time of your coding. Maybe constants 0.1% of the time, but it's almost always going to be local variables like this and instance variables with the @ sign in the front. The last topic I want to cover in this last 15 minutes that we have is I want to create let's say I want to create a giant, we'll call this address.rb. I have an address, and I want to enter this into the database. We're starting to move into that database kind of mindset. So I have a class called address, and as of right now, it doesn't really do anything except for take in a bunch of information. Let's do first name, last name, street 1, street 2, city, state, country, and postal code. I'm going to make each one of these adder readers. All these are going to be instance variables for right now. So down here, if I wanted to call it, I would just call this address 1 or something like that. I'm passing in Jeremy Flores from 123 Fake Street in apartment yes, Seattle, Washington, 98115. Now, what happens if you don't have a street 2 attribute?
It's gonna blow up.
I mean, you could just pass in an empty string like this. But what happens if you're just kind of like, I don't have a street 2, so I'm just going to ignore it. Let's start off with the first one. See if this works. Ruby address.rb. Nothing happens. That's good for me. What if somebody doesn't have a street 2? Like if you don't live in a city, you generally speaking, you don't have a street 2 because you live at one particular house on one particular street. I run this now. This is going to blow up. It says, I expected 7 arguments, but you gave me 8.
Can't you just give like street 2 a default value?
I could give street 2 a default value. Kind of like nothing, like this.
Yeah.
All right, let's see what happens. Everything works, but let's do a few things. Let's create all of these to be adder readers real quick. Adder reader, first name, last name, street 1, street 2. City, state, country, and postal code. All my spaces to 2. Okay. So I have address 1. Let's do a whole bunch of stuff. We'll do p address 1 dot street 1 and street 2. Let's see what we get. So again, let's go back to the way things were before. I'll just do apartment 2. So what do you expect to get for lines 18 and 19 here?
The 123 Fake Street for street 1 and apartment 2 will override the default value.
Yep. So we expect 123 Fake Street to be saved as street 1. If you don't give me any street 2, I will let you know what street 2 is. And it'll say apartment 2 is going to be street 2. So I expect to get 123 Fake Street and apartment 2. 123 Fake Street and apartment 2. Everything looks like we expect. If I were to not pass anything in, you said that you would actually get street 2 just being empty strings. So you would expect this to be 123 Fake Street and street 2. Correct? Let's see if that, or just empty string. I'm sorry. Yeah. Let's see what happens. Okay. That looks good to me. What if you mix things up because some forms ask you for your last name first? So if it did Flores and I did Jeremy over here, let's get rid of these 2 for a second. Did p address 1 dot first name and p address 1 dot last name. My first name now becomes Flores and my last name becomes Jeremy. What if I switch around my country and my postal code by accident? What if I switch up street 1 and street 2? What if I pass in anything in the wrong order? You know, this is the idea where it's like this code as of right now is extraordinarily brittle. Because if it's expecting everything in a specific order every single time. So I have 1, 2, 3, 4, 5, 6, 7, 8 things that I need to pass in. You have to memorize that order every single time. You have to pass it in every single time. And if you mess anything up, you're going to be saving somebody's like postal code as their first name by accident. Obviously, this doesn't happen very often, but you can kind of see like this is starting to become very, very brittle. It's requiring it in a very specific thing every single time. Otherwise, it's going to blow up. This is not the greatest way that you want to do things. Aaron, you had a quick question.
I need to take a look more at that, at your adder readers.
Mm-hmm.
Like right now, they're being declared as symbols, basically.
Right now, they're being declared as symbols. Yeah, this is just unfortunately how adder readers are written. Yeah, but that's how the list of adder readers is going to be done. It has to be done in a list of symbols.
Okay, and so everywhere the first name appears,
Mm-hmm.
it is going to attribute that to one of those adder readers.
Yes. So adder reader first name is shorthand for this method. So whenever you call first name as a variable or like dot first name, it's actually just a method that reads the instance variable. This adder reader first name is synonymous with line 15. This block at 15, 16, and 17. It's just a lot easier to read than having 3 lines of code.
So then we can basically, if we do have an adder reader, but we don't actually declare it as an instance variable, if we use it within a method, is that going to blow it up?
So in order to use an adder reader, let's say I wanted to create some other thing like a def anything else, and I wanted to create a new instance variable. All I have to do is declare it one time, and then from everywhere else, I can just call new instance variable.
What if we have an adder reader that's the symbol is an instance variable, but then within the method, we get rid of it.
That's exactly what I just did. So instance variables don't always have to be set directly in the initialize. I can set it in pretty much any other method. So I've declared it here on line 16. So if I call anything else, the method anything else, it'll set a new instance variable called 123. I've added it to the list of adder readers up here. This is getting a little bit more advanced, but I've listed it up here in the adder readers. So which means that if I do something else after I call anything else, I can just call it like this on line 20. And again, for most people, like you don't need to know this right now. The main thing you need to know is create it. Everything goes in the initialize, create it as an instance variable, add it to adder readers, and you can use it anywhere else. Going back to this, right now we have, again, an address with 8 things in a very, very specific order. It's very brittle at this point because in case I switch anything by accident, and there's a lot of user error, everything will kind of get ruined inside of your database. You're going to have a city of your first name or the state of a country code or something like that. It's very, very possible that this could happen. So how do we avoid this? Instead of doing it the way that we've done, what we'll do instead is pass it in as a hash. So instead of accepting 8 parameters, I'm going to pass in 1 parameter. This 1 parameter has key value pairs so that it doesn't even care which order that you put it in. All that matters is that it's all in 1 hash and you're accessing it by the key. So we'll just call this address. Let's just call this CP address. First name goes to Rod. Maybe we'll do country. It's the USA. I'm just going to go purposely very, very out of order. Street 1 goes to 73 West Monroe. Street 2 goes to 303. I'll do last name, Levy. What else am I missing? City goes to Chicago. And I think the only thing left is postal code, right?
State, I think. Oh, you have.
I don't have state. Let's just throw it here. Why not? I'm going to mess everything up. Postal code is going to be 60603. So you can see, like, you can pass it in whatever order that you want, but when I pass this entire hash into the address hash, I'm assigning the instance variables correctly based on the keys of the hash. So, oh no, let's copy this and put it here, undo a bunch of times. Go back and let's move this outside. I'm just going to create a new address with CP address. And I'm going to look for first name, last name, and we'll take a look for postal code or something like that. We have some syntax errors. Did I mess something up? Am I missing a comma anywhere? There. Crowd levy 60603. Oh, when you use my general rule is if you're passing in more than 3 parameters, I want you to move over to using a hash. It's less brittle. 1 or 2 things, that's totally okay. 3 things, you're pushing it, but it's also okay. Once you get to 4, then you have to memorize like which order I'm passing things in, right? It's kind of like if you go to if you've ever gone to the DMV, right? And they say, fill this form out, then fill this form out, then fill this form, then fill this form out. And then if you fill it out of order, they could say like, actually, like you have to go back, you have to fill this form out, get a stamp on this one before you can come back to me. And then that's the idea of like brittle software. If you have to pass a very specific order, like you're asking for trouble later down the road. So maybe 1, 2, 3 parameters, you're good to go. Just pass it in an order. That's okay. Once you get to 4 and onwards, you want to use a hash. Is this clear in terms of like why we would want to use something like this versus what we had earlier, which was just like a very large list, long list or something?
Oh yeah. Basically, what you're saying is that with the hash, it's going to sort it out for us.
What's that? It's going to sort it for you. Like, so you pass it in, you just pass in the information, and then in your class itself will sort things out for you. Or if I even wanted to create a new address, so address 2, it's going to equal address.new, and I just wanted to pass in certain small things, like maybe I'll do street 1 is a 401 North Wabash, and street 2 is actually the location of Trump Tower, something like that. I don't need to pass in everything. I can just start with one small little bit.
No, we know where you live.
I don't live at Trump Tower.
Oh.
What's that?
With 3-inch carpet.
So it's like I can pass in the things that I want to pass in. Like I don't need to pass in everything all at one time. Maybe I can do maybe I can just pass in street 1 and street 2 for now. Maybe I'll add more stuff in a little bit later. But this is, you can kind of see this is a little bit more flexible than passing things like 8 things at one time in a very specific order. If it's out of order, you're screwed. If you miss something, you're screwed. You know, so that's the kind of the idea behind doing things with hashes. So just to recap, if you're passing in 1 to 3 things, that's okay. You don't need to do the hash thing. Once you get past 3, you want to start passing it in as a giant hash. Okay. We have a few challenges for today. We're going to be working, this is the first time we're going to try this. We'll have remote pairing with in-person. Now there's going to be one remote person who's not going to be pairing with in-person because Danny's not here until the afternoon. So for this morning, we're going to just kind of pick and choose a pairing partner that you want to use. And using Slack will be your biggest benefit here. There are 2 challenges. Again, we moved from 20 challenges a day down to 1 or 2. One of them is called apple trees, and the other one is basically just bowling. Apple trees, the idea behind it is I want you, the object of this challenge is to essentially make you think of the objects you're creating inside of Ruby as real life things. So if I have apple tree and apples or something like that, every single apple has a diameter. It has color. It has certain attributes about it. An apple tree can return its height to you. It can grow. It can age. It can bear fruit and things like that. You're going to implement all of that over here. And the other one is bowling. I've actually never learned how to like figure out how to actually calculate bowling scores correctly until I had to do this challenge. So you're going to create a bowling game using object orientation to basically like figure out all the logic, what instance variables you need, what kind of methods you need as well. These are not terribly difficult in terms of algorithms. Like it's pretty simple to figure out bowling scores, but the challenge is like, how do I understand object orientation? We're going to spend this whole week on object orientation. And with that, it's 11 o'clock. I'm going to stop recording here. And in person, you're going to have one-on-one time with Rod. And yeah, just pair up remote with in person today. If you don't have headphones, bring headphones. I think we have an extra pair or two or something like that. Any questions from remote? No? Okay, fantastic. We'll get started.
Reiterating